The most common score for this A-level maths question? 0. In fact, a quarter of students sitting this paper didn't even score a single mark in this question. Only the very best A-level maths students were able to score full marks, but even they found it very, very challenging. Let's see why. It says, given that the denominator of this fraction here isn't 0, prove that this equals this for 4 marks. So we need to show step by step how we can turn one side of this equation into the other side. So we first need to decide, are we going to start with the left-hand side and try and turn that into the right-hand side? Or are we going to start with the right-hand side and try and turn that into the left-hand side? What do you think? Notice that on the left-hand side of this equation, we have a mixture of angles. We have theta, 2 theta, and 3 theta. Whereas on the right-hand side, all of the angles are theta. So there's more to do on the left-hand side. We can use trig identities to turn these 2 thetas and 3 thetas into thetas. So we're going to start with the left-hand side and try and turn that into the right-hand side, step by step. So what trig identities might we need to use here? Well, I'm noticing here on the left-hand side that we have a cos squared, but there's no cos on the right-hand side. But there are sines. What identity do you know that involves sine and cos? Well, this one's giving you a clue. It's cos squared. You should know that sine squared plus cos squared equals 1. So that could be a very helpful identity for this question. What else might be helpful? Well, here we've got a cos 2 theta, and on the other side we've got sine theta. So you should know an identity for cos 2 theta. There are 3 of them, but the one that we're going to need to use here is the one that involves sine theta. In fact, it's 1 minus 2 sine squared theta. Finally, we're going to need to convert this sine 3 theta into something that involves sine theta. So to do that, we can use the addition rule. We can note that 3 theta can be rewritten as 2 theta plus theta. And then we can use the formula in the formula book for sine of a plus b to rewrite this as sine 2 theta cos theta plus sine theta cos 2 theta. So that's using the addition rule. So let's start with the left-hand side. And the first thing that we can do here is to replace the cos squared using this first identity with 1 minus sine squared. What else can we do? Well, we can replace the cos 2 theta here with 1 minus 2 sine squared theta. So that can go in there. And we can replace the entirety of this sine 3 theta with what we've got here. But we're going to need to put that all in brackets so that the minus sign that we have on the outside here applies to everything within those brackets. If you get that far, you get your first mark. Next, we can expand these brackets, applying the minus sign to both items. What next? Well, if we look at what we're aiming for on the right-hand side, we have thetas. So this is okay, this is okay, this is okay, and this is okay. But what is not okay is to have the sine 2 theta, that's going to be a problem, and also the cos 2 theta. So there's another identity that we're going to need here. That's the identity for sine 2 theta. You should know that that is 2 sine theta cos theta. And again, we're going to use the identity that we had up here for cos 2 theta, which said that that was 1 minus 2 sine squared theta. So notice now that we don't have any 2 thetas or 3 thetas left over. Everything now is involving a theta. Next, we can tidy this up. That becomes 2 sine theta cos squared theta. And here we can expand the brackets, giving us a minus sine theta. And be careful with this one. Minus minus gives us plus 2 sine cubed theta. Look again at the goal. What did the goal involve? It involved numbers and sine thetas. So I don't mind these sine thetas that we've got here and here and here and so on. But I do mind this cos squared theta. We're going to want to convert that to sine squared. Again, using the identity sine squared plus cos squared equals 1, cos squared would be 1 minus sine squared. So again, we can expand the brackets here, and that will give us here minus 2 sine theta plus 2 sine cubed theta. Next, we can tidy this up, collecting the like terms here to get minus 3 sine theta, and the like terms here to give us plus 4 sine cubed theta. Now, you might be looking at the goal and starting to worry here, because on the top of the fraction, we have 1 minus sine squared theta, but within our goal, we have 1 plus just sine theta. But you should spot something. You should spot that the top of the fraction that we have here is a difference of 2 squares. So we know that that can be factorized as 1 minus sine theta and 1 plus sine theta. So that's where the 1 plus sine theta is on the top of the fraction here. That's where that's coming from. It must be that this other bracket here must cancel out with an identical bracket on the bottom. So that's telling me that one of the brackets on the bottom must be 1 minus sine theta, so that it would then cancel in the final step. What would the other bracket be? Well, we don't need to do any fancy polynomial long division or anything like that, because we have it here in the question. We can simply copy that down. I mean, you can verify that it works. If you expand these brackets, you will end up with what we had before, the line above. So we can see that this will then cancel with this to leave us with the goal, which is the right-hand side. Part B starts with the word hence. It says hence, solve, so work out what theta is, upon this interval between theta is between 0 and 360, the following equation. Give your answers to one decimal place. So this word hence means use something that we've done previously to help you with what you're about to do. So can you see a link between what we have here in part B and what we've proved in part A? Yeah, hopefully you can spot that this part is the same as this part. So that's suggesting that we can therefore replace this part with what this is equal to. We can replace it with this. So that can go in there. So that's giving us our first couple of lines of working. We'll copy down the question, and then we're just replacing this part with what we had in part A here. Next, you should know that cosec theta is 1 over sine theta. I remember that by looking at the third letter of cosec. The third letter is an S, and sine starts with S. 1 over sine is cosec. So this is 2 over sine theta. Next, we have this fraction equaling this fraction. Let's eliminate the fractions by cross-multiplying. Then we can expand the brackets, and we'll end up with this. And if we bring everything over to one side to get equals 0, we'll have 9 sine squared plus 5 sine minus 2 equals 0. If you try to factorize that, you'll discover it's not possible. In fact, we have to use the quadratic formula here, or I suppose you can complete the square. So let's quote the quadratic formula using algebra. Edexcel say that if you use a formula, you should quote it using algebra first. Then we'll substitute in the values of A, B, and C. And then putting that in the calculator, we get 2 decimal values. I'm going to give them here to quite a high degree of accuracy because at the end, I want answers correct to 1 decimal place. So I don't want to round too much too early. But these are for sine theta. We were asked to solve this. We're looking for theta. So we need to apply arcsine to each of these, arcsine to this, and arcsine to this. Make sure your calculator is in degrees mode. How do we know we're in degrees mode? Well, look at the angle that we were given for theta in the question. It talks about 360 degrees. Your calculator will give you this solution when you type in arcsine of this, but there is a second solution within this interval. How do we get it? Well, I call the value that the calculator gives you the A solution. The second solution, the B solution, we can get by doing 180 minus the A solution. That's because this length here is the same as this length here. So we're measuring to the left of 180 by A to end up with a B solution here. So I'm going to do 180 minus the value the calculator gave me for my second solution. All other solutions to both the A solution and the B solution here would be multiples of 360 degrees apart. But that would take us outside of this interval. So I don't need to worry about any more solutions for arcsine of this value. What about arcsine of the other value? Well, the calculator gives me this value. That's what I would call the A solution. But I can get another solution, the B solution, by doing 180 minus that A solution. Now I appreciate that the A solution itself is outside of this interval. So we will need to reject that A solution. However, we can use that A solution to get another solution that is within this interval. So though I'm rejecting the A solution, I am going to still use it by taking the A solution and adding 360 degrees to it to get another solution here, which is within this interval. If you do the number crunching on these 4 solutions and round appropriately to 1 decimal place, you'll end up with this set of solutions here for your final couple of marks. I think that might be one of the most tricky questions on trigonometry that I have ever seen in an exam at A level. Have you found one that's trickier? Let me know in the comments, and let me know how many marks you think that you would have scored. Would you be one of those students who scored 0 marks? I hope not. Remember, even if you can't prove part A, you can still use the result that they've given you to attempt part B. Never give up altogether. Always try the following parts, even if you can't do the first part completely. Maybe you can do something.